Hey, welcome back. In this episode, we're going to learn about how to recommend a solution for data integration. Azure Data Factory is a managed cloud service that's built for these complex extract transform load or extract load transform, which is known as ETL or ELT, and data integration projects. Azure Data Factory is a cloud-based ETL and data integration service that allows you to create data-driven workflows for orchestrating data movement and transforming data at scale. Using Azure Data Factory, you can create and schedule data-driven workflows called pipelines, and that can ingest data from disparate data sources. You can build complex ETL processes that transform data visually with data flows or by using compute services such as Azure HD Insight Hadoop, Azure Databricks, and Azure SQL databases. Also, you can publish your transformed data to data stores such as Azure SQL Data Warehouse or business intelligence applications to consume. Ultimately, through Azure Data Factory, raw data can be organized into meaningful data stores and data lakes for better business decisions. Now, let us learn about how this data factory works. Data Factory contains a series of interconnected systems that provide a complete end-to-end platform for data engineers. The first thing we need to learn about is how to connect and collect. The first step in building an information production system is to connect to all the required sources for data and processing, such as software as a service services, databases, file shares, and FTP web services. The next step is to move the data as needed to a centralized location for subsequent processing. With Data Factory, you can use the copy activity in a data pipeline to move data from both on-premises and cloud source data store to a centralized data store in the cloud for further analysis. For example, you can collect data in Azure Data Lake storage and transform the data later by using an Azure Data Lake's analytics compute service. And you can also collect the data in Azure Blob Storage and transform it later by using the Azure HD Insight Hadoop cluster. Another way is to transform and enrich the data. After data is present in a centralized data store in the cloud, processors or transform the collected data by using ADF mapping data flows. Data flows enable data engineers to build and maintain data transformation graphs that execute on Spark without needing to understand Spark clusters or Spark programming. If you prefer to code transformation by hand, ADF support external activities for executing your transformation on compute services such as HD Insight Hadoop, Spark, Data Lake Analytics, and machine learning. So what about CI/CD and how can you publish the data? Data Factory offers full support of CI/CD for your data pipelines using Azure DevOps and GitHub. This allows you to incrementally develop and deliver your ETL processes before publishing the finished product. After the raw data has been refined into a business-ready consumable form, load the data into Azure Data Warehouse, Azure SQL Database, Azure Cosmos DB, or whichever analytics engine your business users can point to from their business intelligence tools. And the last step is how can you monitor all of this? After you have successfully built and deployed your data integration pipeline, providing business value from refined data, monitor the scheduled activities and pipelines for success and failure rate. Azure Data Factory has built-in support for pipeline monitoring via Azure Monitor, API, PowerShell, Azure Monitor Logs, and health panels on the Azure portal. Let's learn about the Azure Data Factory key concepts. An Azure subscription might have one or more Azure Data Factory instances. Azure Data Factory is composed of four key components: And these components work together to provide platform on which you can compose data-driven workflows with steps to move and transform data. The first thing we need to learn about is pipeline. A data factory might have one or more pipelines. A pipeline is a logical grouping of activities that perform a unit of work. Together, the activities in a pipeline perform a task. For example, a pipeline can contain a group of activities that ingest data from an Azure blob and then runs a Hive query on an HT Insight cluster to partition the data. The next one is mapping data flows. You can create and manage graph of data transformation logic that you can use to transform any sized data. You can build up a reusable library of data transformation routines and execute these processes in a scaled out manner from your ADF pipelines. Data Factory will execute your logic on a Spark cluster that spins up and spins down when you need it, and you won't ever have to manage or maintain clusters. The next concept is activities. Activities represent a processing step in a pipeline. For example, you might use a copy activity to copy data from one data store to another data store. Similarly, you might use a Hive activity, which runs a Hive query on an HT Insight cluster to transform or analyze your data. Data Factory supports three types of activities: data movement activities, data transformation activities, and control activities. The next one is data sets. Data sets represent data structures within the data stores which simply point to or reference the data you want to use in your activities as inputs or outputs. Linked services are much like connection strings, which define the connection information that's needed for Data Factory to connect to external resources. Triggers represent the unit of processing that determines when a pipeline execution needs to be kicked off. And there are different types of triggers for different types of events. A pipeline run is an instance of pipeline execution. Pipeline runs are typically instanced by passing the arguments to parameters that are determined in pipelines. And these arguments can be passed manually or within the trigger definition. Parameters are key value pairs for read-only configuration, and parameters are defined in the pipeline. And control flow is an orchestration of pipeline activities that include chaining activities in a sequence branching, defining parameters at a pipeline level, and passing arguments while invoking the pipeline on demand or from a trigger. So how can you integrate Data Factory and Databricks? You can use Azure Data Factory to ingest raw data collected from different sources and work with Azure Databricks to restructure the data to meet your requirements. So the steps involved are: first, you will create an Azure storage account, which you will use this storage account to store your ingested and transformed data. Then you will create Data Factory instance. So this is after you set up your data storage account and create your Data Factory instance by using the Azure portal. The third step is create data workflow pipeline. So to create a pipeline, copy data from your source by using a copy activity in Data Factory. A copy activity allows you to copy data from different on-premises and cloud sources. Fourth step is to add a Data Factory notebook to the pipeline. And this notebook contains the code to transform and clean the raw data as required. And the last step is to analyze the data. Now that your data is cleaned up, use Azure Databricks notebooks to further train the data or analyze it to output the required results. That concludes this episode. In the next lesson, we are going to learn about data warehousing and big data analytics. I will see you on the next one. Until then, take care.